Hello everyone. So we are in the series of TH diagram. So here is the TH diagram: temperature versus entropy. Temperature on y-axis, entropy on x-axis. So you can see this is L for liquid, V for vapor, and L plus V is liquid plus vapor. So on TH diagram, the line which I have drawn by black, you can see here, this black line. This is called as a constant pressure line. So this line is called as a constant pressure line on TH diagram. Okay, so this is the T sat, that means for this particular pressure, this is the saturation temperature. As you'll increase the pressure, you'll get different saturation temperature. As you'll increase the pressure, T sat will increase. If you'll decrease the pressure, T sat will decrease. Okay, so this line from here to here, this is called as a saturated liquid curve. You can see here, saturated liquid curve. And this from there to here, it is called as a saturated vapor curve. And the point where saturated liquid curve and saturated vapor curve meets, that is called as a critical point. So three things we have discussed: saturated liquid line, saturated vapor curve, and critical point. And this is the constant pressure line, and this is the T sat corresponding to constant pressure line. Okay, so before this saturated liquid curve, the region is called as subcooled region or undercooled region. Okay, the area under this dome, under this you can see L plus V, I have written as a wet region. So wet region means liquid plus vapor. So here liquid also prevails and vapor also prevails. Here if you come at this point, we have 100% liquid, and liquid starts to boil or starts to convert in vapor. As you move forward, slowly liquid is going to convert into vapor. If you come here like this, then liquid will decrease and vapor is going to increase. And if you come at this point, this is 100% vapor line. Okay, so here all the liquid has been converted to the vapor, and this particular heat between this both, this is called as an latent heat corresponding to this pressure. Okay, so this is latent heat, and here is vapor. 100% vapor lies on saturated vapor curve, and above this side if you go, this is V written here, and this is superheated region. Okay, if you heat from this point, the line will go to superheated region. Okay, so subcooled region, wet region or liquid plus vapor, and superheated region. Okay, three things we have understood. So this is how the TS diagram is shown. Now we are going to discuss TS diagram of Rankine cycle. Okay, so you can see here Rankine cycle TS diagram is drawn on the board. So first of all, see point 1 to 2. Point 1 is lying where? In superheated region. So here there is a steam which is in superheated region or superheated. Okay, so in turbine what happens? Superheated steam is expanded. You can see from 1 to 2. How? Isentropically. So when steam expands, so temperature is going to decrease. Okay, you can see point 1, point 2, temperature from T1 to T2, and T2 is less than T1. But entropy is constant. Why? Because it is an isentropic process. So steam expands and we get work output, that is shown by WT. Okay, after that 2 to 3 is which point? This is the condenser. Okay, already I have explained in the line diagram. Okay, so 2 to 3 is the condenser. What happens in condenser exactly? There is the rejection of heat. Okay, so from 2 to 3 you can see there is a Q2 equal to heat rejected. Heat is being rejected, and this lies in wet region. Okay, liquid plus vapor. So after rejecting heat, we get point 3, that is vapor or steam is converted into liquid. So 3 is the 3 point lies on saturated liquid line. After then pump comes to picture. Okay, pump. So we are giving work input to the pump. You can see arrow, it is inside. Okay, here was outside. Why? Because this was an output and this is an work input. So we are giving work input to the pump. Then pump is able to pump the water from point 3 to point 4, and we get a point 4. This is also isentropic. Okay, most ideal case we are assuming. And from 4 to 1 you can see this is the constant pressure line on TS diagram. I have explained how to draw constant pressure on TS diagram. So 4 to 1 you can see, so heat is added in boiler. How? At infinite temperature difference and at constant pressure. Why I am saying infinite temperature difference? You can see here 4 to 1 there is a more temperature difference here. 1 and 0.4. So heat is added in the boiler. How? Q1, you can see Q1 is equal to, Q1 is heat added, and in Rankine cycle heat is added in boiler at constant pressure or at isobaric process 4 to 1, okay, and temperature increases. You can see 4 and T4 and T1. T1 is more than T4.